It's a good day, Ignite students. Welcome. Here we go. We've got some earthquake. Well, of course, that's how the thing starts out. We got some earthquakes to talk about. Everything's shaking here. All right. Earthquakes happen in zones. Let's just go. Earthquakes happen in zones. 95% or more of all major earthquakes happen in narrow zones. You'll see this simple oversimplified map here. We've got, this is the Pacific Ocean. We've got this huge ring of fire, okay, where we've got all this volcanic activity, but you've also got earthquakes. So all along the west coast of South America, the west coast of North America, the Alaska, the Aleutian Islands come across, and you go across Japan, the Philippines, Indonesia, Australia here, and then all of these earthquakes. And then what else? Oh, here's the Mid-Atlantic Ridge, all of these earthquakes. All right. You've got a series here across the Mediterranean, but you've got these zones of earthquakes where the major earthquakes happen. They're related. The fault movement is related to tectonic plate movement, but we already knew that. So these are earthquake zones. These are where lots of things happen. And so we just need to get a sense of what's going on. All right. What's intensity? What's magnitude? Well, first of all, intensity right now for earthquakes, intensity is not really a number. Intensity is kind of a damage measurement, how bad the shaking was, okay? So, sorry, wrong slide. Intensity is just how bad the damage was. Magnitude is a number. Richter scale has been used for years, and the Richter scale is really old. Richter scale's not used anymore. They don't tell you that. It's still reported on the news. It's still reported. In fact, sometimes, like, if you ever really carefully listen when they talk about a tornado, they say the EF5, EF4. Well, the E is enhanced. It's the enhanced Fujita scale instead of the old Fujita scale. So they modified the scale of what's a 1 through 5 on a tornado. The Richter scale is gone, and they've got a new measurement that's actually used, and then they kind of relate it back to the old Richter scale when they report it. The Richter scale is good if the earthquake is shallow and it's nearby, less than 500 kilometers. Okay? So 300 miles. That's when the Richter scale is good. Let's look here. What you do is you take the distance and you take the amplitude of the biggest wave. So you measure this biggest wave and you put the amplitude of that over here. And then you draw a line across, and that tells you it's number 5. That's it. So this comes out right here at 20. What happened if I had a wave that was 1/10 that was down at a 2, and I drew a line from here to a 2? We go right across this 4. What's not often stated about the Richter scale is it's logarithmic. What does that mean? That means it doesn't go from 0 to 10 or 0 to 7. That means to go from a 1 to a 2, the 2 is 10 times bigger than the 1. If this was a 2 centimeter wiggle over here, this is a 20 centimeter wiggle over here. It's a 10 times bigger wiggle to go from a 4 to a 5. The wave amplitude is tenfold. So that means a 3 is 10, 4 is 10 times bigger than a 3, and a 5 is 10 times bigger than that. So in your head, think of this has 2 zeros, this has 3 zeros, this has 4 zeros behind it, right? Not really. But that's a way to keep in your mind that it's logarithmic. It should be getting much bigger. That's something interesting about the Richter scale that's often understated. In fact, the magnitude, I may link this in the comments. I'm not going to play this video. This is a good explanation of what's going on in the video. This one we can, I want to show you this.
We're all pretty used to hearing about its magnitude. A 5.8 for the Virginia 2011 quake, a 7.0 for Haiti's devastating quake in 2010. But what exactly do those numbers mean? They represent the energy an earthquake releases, basically how powerful it is, and the numbers build exponentially. And that can be a hard thing to picture. That's why this animation
Loma
is
Prieta,
so
this is the
handy.
1989
It
World
shows
Series
just how
earthquake we
big
talked
the difference is from
about.
one magnitude
And then
to
there's
the
two
next.
others that also have that same
Each
measurement.
magnitude is basically 33 times more powerful than the last. That means a magnitude 7 earthquake is 33 times more powerful than a 6. So take a look at that 5.8 Virginia quake. It looked pretty small compared to those 6.9 quakes. But compared to that 7.7 Sumatra quake, it looks tiny. And it's all because of this exponential scale. It builds fast, by a factor of about 33 with every jump. So the difference between two magnitudes, between a magnitude 6 quake and a magnitude 8, is 33 times 33, or 1089. Do the math, and a magnitude 9 earthquake, like Japan's catastrophic Tohoku quake in March 2011, is 35,937 times more powerful than a magnitude 6. Even though we've gotten really good at measuring
Alaska
quakes,
64.
it's still impossible to predict them. Scientists can't say when the next colossal earthquake will happen, but
Okay. The scale of the video is what matters. Is that the circles are actually a good way to show you that area is getting significantly bigger. And when they talk about moment magnitude is what's replaced the Richter scale. So you only need a couple things to talk about moment magnitude. You need the strength of the rock. The strength of the rock that's going to move across. Like, is it limestone? Is it shale? We talked about hardness when we were talking about minerals and rocks last semester. So what's the strength of the rock? How much of the fault? Like, the fault's thousands of miles long, right? How much of it actually moved? And then how deep was it? So what's the area, the length of the fault that moved times the depth that moved times the strength of the rock? Length, width, strength. You multiply all those and you get the moment magnitude, which tells you the energy released in an earthquake. All right? Here's something interesting. There are lots of earthquakes going on. There are lots and lots and lots of earthquakes. 10,000 4.0s per year. 10,000 a year. Okay? So when you get to a 5.0, now you're only 1,000 a year, but you're like, wait a minute, that's almost 3 a day worldwide. And if you have one, you have an aftershock. So sometimes they're clustered like that. That's fine. That's true. But again, we'll look at some of these dates. So Long Island in 1884, that's a 5.5. The Loma Prieta, that was the 6.9 right there. Charleston, South Carolina, that's an old one at a 7.0. San Francisco, the 1906 earthquake we've looked at. Alaska, 64. These are huge. So this narrowing pyramid shows you the rarity of it, and moving up, equivalent kilograms of explosive, 56,000, 1,800,000. This is the 32, or they called it a 33 multiplier, moving up. So moderate lightning bolt, big lightning bolt, tornado, atomic bomb, Mount St. Helens. So the amount of energy that's released, this is other things that release that amount of energy, just comparisons. Same image with some different, Alaska 64, Chile, the California, Northridge, California 94. That was another one. Long Island, same thing. And then here's some descriptions, moderate earthquake, property damage, light earthquake, maybe some damage, major, great. Those are just different ways to look at this same thing in the number per year. Oh, sorry, same image. Okay. We've got an assignment to look up some famous earthquakes, or I'm going to leave that for the assignment. We're going to have a little fun with history today. There's a lot of modern parallels. I don't even want to say the phrase of what I want to say right now. There are a lot of modern parallels for what's going on with what we're going to talk about. But we're going to go back. We're going to go back to 1990. We're going to look at one man, Iben Browning. Iben Browning is a PhD. He's a professor somewhere. He's got all this. He's a consultant. He's a self-proclaimed climatologist. And he thinks earthquakes are related to tides. He thinks that volcanic ash causes climate cooling and that the Earth's about to change climates and all this stuff. And he can predict earthquakes. Isn't that amazing? Years and years before anybody else, he alone can do this cool thing. He predicted that December 3rd, 1990, the New Madrid Fault would go off with a major earthquake. He said it was a 50-50 chance that on that day or within 24 hours that there would be a major earthquake on the New Madrid Fault. And people around here lost their mind. It's absolutely wild how much they paid attention to him. There was a little bit of a party atmosphere. There was a little bit of a like end of the world thing. There were all sorts of people were laughing about it. And then if you ask them again, they were really serious and they were really panicked about it. There were people who knew nothing was going to happen and cutting up and like making fun of it. And there were other people who were legitimately scared something was going to happen. But we got to put this in a little bit of context. October of 1989, massive Loma Prieta, the World Series earthquake, collapsed the deck of the bridge. The Game 3 stops. I hope you watched that video last time, the ESPN or the newscast went afterwards. Stopping the World Series, the earthquake, everything that happened. That's October of 89. And this guy comes out and says, we're going to have the big one here in 1990, in December of 90. There were all sorts of stuff going on. I want to show you, I've got a few links here, and I'm going to add these to Canvas so you can look at them. 30 years ago, the day Iben Browning predicted the big one would rock our world. This is St. Louis Post-Dispatch, okay? People were hoarding water. People were taping up windows. People were like carrying extra CB radios in their vehicle because 1990, you don't have cell phone adoption. You don't have internet. You don't have any of that. You got landlines. Maybe you've got cable TV or you've got an antenna on your roof. You've got 2 landlines in the house. Maybe you've got the people were losing this stuff. All right. He said New Madrid Fault's going to go off. All right. He related it to all this stuff. He predicted it. This is a 30-year-old. There were national news networks parked in New Madrid, Missouri, with big satellite trucks broadcasting live days leading up to this. Okay. There were people making joke songs about it, bands doing all sorts of stuff, crazy stuff. They did a St. Louis Public Radio did an entire, I guess, a half hour. It's a little slow at first, but they bring in people. They talk about the actual science of it, and they talk about some of the hysteria, and they talk about what would that hysteria have been like if people had had the internet? Like, how does that relate to today? They kind of get into there. There is a New Madrid Fault. It could be time for the big one. The series of earthquakes in this region in 1811, 1812 are documented. Like, not just there was an earthquake, but like days and dates. There were significant numbers of earthquakes in a big one. All right. So this is 1990. Here, the U.S. Geological Survey put out a publication on everything that happened in the response to what he said and the way people reacted to it. This is an official government document covering the response. So this is an ad in the paper. A major earthquake has been projected by Dr. Browning to strike the area on December 3rd. Should you prepare now? He is a remarkable man. His track record. Okay. Oh, this quote right here. Dr. David Stewart, Center for Earthquake Studies, Southeast Missouri State University. Didn't say he could predict earthquakes. Just said he's perhaps the most intelligent person I've ever met. Sure. This is selling videos. He did an interview, and this is an ad selling videos. So it would be paid YouTube content, or you gotta go to Patreon or whatever. I don't know anymore what with the modern. It's in the back of the paper in the in the classifieds, right? Should you prepare now? Help you decide. Eye-opening videotape. Like, this is an ad that ran in the St. Louis papers and a couple like little cash book journal, like really really small papers. You can scroll through this. My computer's going really really slow on this PDF right now. Sorry. There we go. So, introduction. There's three. There's TV trucks. There's all sorts of craziness going on. No earthquakes as large as a 6 occurred anywhere from November through December that year as large as a 6. I'll tell you, I was a student. There were several local school districts that canceled class that day. Like, people were hysterical about this stuff. Okay, let's look at a couple other resources real fast. New York Times. Okay, I just had it up. Oh, there it is. So this is the original article in the New York Times of September 27th of 1990. Why is there an article September 27th of 1990 in New York? Because September 26th of 1990, there was a 4.8 earthquake in New Hamburg, Chaffee. That's it. When that one happened in September, from that day through his predicted day in December, people were nuts. I remember I was in class, and I don't remember feeling the shaking. I don't remember whatever. I just remember looking around and everybody's under their desk. Like, I remember we laughed at the one kid who was in the bathroom when it happened, describing what he thought was going to happen. That was because he was the class clown. He made a great story out of that whole thing, right? 4.8 in Chaffee, and then another 2.8 or 3.0 like 12 hours later that night, just same spot. This is it. Like, when you've got that's a significant earthquake in a region that doesn't have anything over 4s, where you start to, like, you can feel it. Something might shake off the shelf. 2s and 3s, you'll sleep through them. Won't even phase you. You could sleep through a 4 unless a whole bunch of things fell off and you broke around you. All right? People lost their stuff. Okay, some good things that came out of it. People were aware. People were prepared. And earthquake preparedness and tornado preparedness aren't that far apart. You should have water and a flashlight and some food and you should have a plan, chargers and batteries and all those things. You should have a safety equipment and a first aid kit and all that. That's all good preparedness. What else came out of it? There is a Missouri Seismic Safety Commission. That was a result of all of this hysteria and hoopla that happened. But other than that, nothing happened. There hasn't been one. It's been over 30 years. There hasn't been the big one. That doesn't mean that an earthquake can't happen. Even while I'm filming this, for irony's sake, it could happen. But we're going to look at your assignment, and I'm going to ask you guys to use this U.S. Geological Survey. We're going to back out of this, and I'm going to show you what I did. By the way, we've talked about big earthquakes for a while. You know what, you guys, it's fine. Don't worry about that. We're going to back out of this. That other thing was LIGO. It's gravity wave detector. These are all about big earthquakes. That instrument is the opposite. It's so sensitive. If a big semi drives down the street, it's shaking all over. Like, it can detect the tiniest little things. So these are about big earthquakes. I promise. Can we back out a little? Refresh. All right, we're going to go back to search. Okay. So if you go to earthquake.usgs.gov, you can look at recent earthquakes. You can look at all these. This is what's interesting. You can pick your magnitudes. You can pick the past week, past month, or custom. And I picked September of 90 because I knew that that's when that one happened. And then I drew a rectangle in there. So let's just go, let's go anything over a 4.5 from 1980 January 1st through right now. Let's draw a rectangle. We're doing this live. Let's hope this works. I will say this is a little funky because you have to actually click on this box. Okay, I guess it wants me to zoom in one more. Yeah, you have to click on the box and let go. All right, and we'll go that way. And I click again. That's my rectangle. We're going to use this. It's really hard. We're going to hit search. So just 1980 to 20 to now. How many things are there have been bigger than 4.5? 2. I didn't know that answer. Of course, the one 4.8 that was Chaffee, and then 1991, right there in Malden. That's it. All right. Yes, the fault goes a little further south, a little further west. I could do this, but in the last almost 40 years, that's all there's been. I'm going to let you, in the assignment, I'm going to talk to you and give you instructions of what you're going to do, but you're going to use something like this, and you're going to tell me a story. Guys, Richter Scale's out. Richter Scale's old. Moment magnitude is in, and preparedness is good, but don't go overboard. Have a great day. Be safe.